In this video, I'm going to be talking about coterminal angles. So before we get to a more algebraic or rigorous definition, let's just look at a simple example. So suppose we have a tire, either a bike tire or a car tire. Now, anytime you have a wheel with a tire, that tire has a valve on it where you would pump or where you would attach an air pump to inflate the tire. So if we have, I ride my bike a lot, and so I'm always frequently pumping up my tires. Now, when I'm doing that, it makes the most sense for me to have the valve in a position that is easy to attach the pump to. And actually, it's easiest for me when the valve is down at the bottom of the wheel. So we have the valve here in this position. Now, suppose I rotate the tire around, or the wheel around, let's pick a different color. Let's say I rotate it around all the way 360 degrees back to that same position. Now, the end result is the exact same. The valve is in the same position, but what I've done is I've rotated it. Say I stop my bike and I'm in the street, but I want to wheel it up onto the sidewalk in order to pump it up. So I might rotate the wheel forward 360 degrees. Okay. Let's say I want to go around a second time. So I want to push my bike a little further. The wheel rotates another 360 degrees, but I get it back into the same position. So I add 360 degrees again. I could keep doing this. I could keep rotating that wheel as many times as I want. In other words, I can add copies of 360 degrees as many times as I want, and I could always end up in that exact same position. This is the idea with coterminal angles. So let's look at an actual definition and then kind of more precisely how this works with angles. All right, so our definition says angles alpha and beta, so this is pronounced alpha, and this is beta, are both coterminal if and only if there is an integer k such that the measure of angle B is equal to the measure of angle A plus k times 360 degrees. So in plain English, what this means is if I have some angle, let's say that angle is 100 degrees, and actually let's say 400 degrees, and angle A measures, 40 degrees, plus k times 360 degrees. So what I want to know is 400 and 40, are those coterminal? Well, they're going to be coterminal if k, when I solve for k, it's an integer. So subtract 40 from both sides, I get 360 degrees equals k times 360 degrees, divide by 360, so k here would equal 1. 1 is an integer, which is what I want. That means these angles are coterminal from each other. So if we look at these two angles, if I have an angle that measures 40 degrees, let's say it's something like this, an angle is coterminal if I go 360 degrees around and I end up in the same position. So if I add 360 degrees to 40, well, 40 plus 360 is equal to 400. So 400 and 40 are in fact coterminal, because if I start at 40, I add 360 degrees, I end up in the exact same position. Now let's look at an example. This one says, given, well, we haven't talked about this yet, but this is a Greek letter called theta. So we use theta very frequently anytime we have an angle. It's kind of like how we use x in algebra. So given theta is equal to 10 degrees, find two positive and two negative coterminal angles in degrees. So visually, if I have an angle in standard position that's 10 degrees, I want to find two positive coterminal angles, so that's going to be going this direction, counterclockwise. And then if I want negative angles, I'm going to go in the opposite direction. So black will be the negative angles, and green will give me the positive angles. So that's visually what's happening. But practically, right, in order to end up at 10 degrees after traveling in the positive or counterclockwise direction, all I do is I take 10 degrees and I add 360 degrees. So 370 degrees would be one positive coterminal angle. And again, if I start at 370 degrees and I add 360 again, that's just going to give me a second positive coterminal angle. So what is that, 730 degrees? Okay, we could just keep going. We could just keep adding 360 degrees to where we end up. So 730 degrees plus 360, I get, what is that, 1090? 1090 degrees, okay? And so on and so forth. So we just wanted two, any of these two, pick two of those. That would be the solution. If we want negative coterminal angles, well, now negative, if I want a negative angle, a negative coterminal angle, I'm going to be going in the clockwise direction. But all we need to do is just subtract 360 degrees this time. So negative 350 degrees, that's a negative coterminal angle, and then subtract 360 again. I get negative 710, right? 6, 7, yeah. I could keep going, negative 710 minus 360 degrees. I get 1070, negative 1070, okay, and so on and so forth. So we found three negative coterminal angles, give two, and that would be the answer for this. And we could check to see if any of these two angles are coterminal with 10. So let's just pick one of these angles. How about negative 710? So we would say is 10 degrees, is that equal to negative 710 degrees plus k times 360 degrees. Okay, so we want to see if k comes out to be an integer. So add 710 to both sides, I get 720 degrees. It's equal to k times 360. If I divide both sides by 360, I get k is equal to 2. So that because 2 is an integer, it's a positive or negative whole number, that kind of confirms that negative 710 is in fact coterminal with 10 degrees. So you could do that with any of these angles, and every time k would come out to be an integer. All right, let's look at a last example here. So determine whether the given angles are coterminal. So first we have the measure of alpha is equal to 190 degrees. The measure of beta is equal to negative 710, 170 rather. Okay, so I just say 190 degrees, is that equal to negative 170 plus k times 360, where k is an integer. So add 170 to both sides, we end up with 360 degrees, k times 360, yes, k is equal to 1, so we would say yes, alpha and beta are coterminal. All right, the second pair we have here is alpha is equal to 150 degrees, measure of angle beta is 880 degrees, so we just kind of plug it into the formula. 150 degrees is equal to 880 degrees plus k times 360. Subtract 880 from both sides. What is that? Negative 730 degrees is equal to k times 360 degrees. Well, if k was equal to negative 2, we would get negative 720 degrees. If k was equal to negative 3, we would get negative 1080. So k is not an integer here. If you divide both sides, integer. If we divided both sides by 360, we would get a decimal number for k. So k is not an integer. What that means is no, A and B are not coterminal.